So, hi and welcome everyone to this session about Spring testing. My name is Mattias Severson and I will be your host for the next hour and a half. So the things that we'll discuss in this session are start off with some basic testing. We start on with some very simple examples and then we see how Spring testing works underneath. We will continue to investigate the Spring support for embedded databases and how that can be applied to testing. Next, we will continue to see how transactions can improve our test if we try to verify the database state. Also look into some Spring profiles and what benefits they give us. Look on the controller tests, the Spring MVC Test Framework. And in the end, we will conclude with some server integration tests. So basically, in contrast to many other sessions during this conference, there's really no news for you here, no new frameworks, no fancy stuff, so it's been around for a while. But in contrast, this also means that most of you can go back home, and when you come to work on Monday, you can start applying these techniques directly without the need for your organizations to adapt anything new, because chances are that you're already using this. So just to give me an idea what your knowledge is or what you're currently using. So how many of you are using Spring 3.2? That's good, that's majority. 3.1 users, anyone? Yeah, a few hands. And still anyone left on 3.0 or older? Oh, I'm sorry. But hopefully there's some good news in here for you as well. So first, briefly about me. Who am I? My name is Mattias. I have a background in electrical engineering, microcontrollers, mobile phones, those kinds of things. But for quite some time now, I have been working as a Java developer. And I'm employed by a consultant company called J-Way, which is based in Sweden. And Sweden is based for Nobel Prize, ABBA, brands like Volvo and IKEA. So that really was beside the point, so let's get down to action. During this presentation, I will have a very simplified application that we will use. So you can imagine, first, you have a project, you're working in a bank. You start off a new project, you have entire team is present, you have an architect there, you have a DBA, you have a DevOps people are there. And for this particular bank also has an outsourcing partner, which will do the hosting of the service for us. So the architect outlines the architecture of application. In the persistence layer, we have an account repository, which maps your account entities. I won't go into how that is implemented, but you should know that it has been decided we use a SQL server and we use JPA for ORM mapping. And using this kind of setup, it means that for me as a developer, that means that somehow I need a database connection. And that could be located on a remote server. But that also means that we are several developers in the team. If we all use the same database for verification, if we're not careful, that will cause clashes, because then we change the state of the database for each other. So that can cause some problem. Another alternative is that we deploy a database on each and every one of our local machines. But then you need to distribute that database. Of course, we could also use a virtual image that someone creates for us. And then when the database updates, we need to redistribute this virtual image somehow. So a little bit to consider there. But since we have DevOps guys in our team and DBA, they promise to take care of that for us. Next layer of the application is the service layer. And this is where all the application logic resides. You can consider this as an API that provides support for all the use cases that we need. it also acts as a security boundary, so if we use method-based security, this is where we would like to use that. It also has acts as a transaction boundary, so any laser-loaded entities that we get from our JPA, they will actually be decoupled before escaping this layer, so we don't get any laser-loaded entities out there that can cause trouble later on. And on top of this, we have our controller layer. And this is just a simple layer. All it does is takes care of the request mapping for us and JSON serialization. With this kind of architecture, you could see that we could easily swap out the controller. We could have some messaging bus there instead, or any other kinds of infrastructure that you need to communicate, because the entire application is in the service layer. Okay, so let's start our project. It turns out, however, that on the very first day of the project, the outsourcing partner server farm crashed. So that means that our DevOps guys and DBA guys, they are out to the outsourcing partners, and they cannot help us with the database setup. So meanwhile, the DBA is doing search and rescue work, saving our current customers' accounts. We get started, see what we can do while we're waiting for that to happen. Starting very simply, this is your typical unit test. I hope you're all familiar with. What we do is declare a field, and in a setup method, we instantiate the field, and then we do a test. In order to turn this into a Spring-based test, we really don't like to create the instances ourselves. So we rely on the dependency injection, right? But somehow we need to get that dependency from somewhere, and we can do that by using the @context configuration annotation, to which we passed either an XML-based application context, or if you're more modern, then you use a Java-based configuration. And this is not all that is needed, because this just declares the location of the application context, but in order to make this fly, we also need some mechanism to inflate this application context. And that is provided by the Spring Unit 4 class runner. And since I take all you guys are Spring users, I guess this is just repetition for you. So this you use on a daily basis without thinking anymore. But what you may not know with the context configuration is that it actually caches the application context for you. So, and the way it caches is that once it has been created, it's put in a static memory. And why does it, and how does it put it in a static memory? It's put in a map, and the key of the map is based on the unique context configuration. So what is unique then? Well, it turns out the attributes that you use with that context configuration, that is, you have the locations, you have the classes, you have the context loader. Those three attributes, together with the active profile annotation that they will present later on, they will, under the hood, Spring will create a key for that, and that key will be placed in the static memory. So how long is the application context cache then? It's turned for the entire test suite. And that is also a bit fuzzy. What is a test suite? Is it just a class? Is it just a single test? It depends on what you're using. If you're using a build script like Maven or Gradle, it's actually cached for the entire duration of that test. But it could also mean if you're an IDE user and you just right-click on a folder, that the application context will be created once, and then it will be reused for each subsequent test in that suite, providing, of course, that this key is unique. If you have a different key, that is, you provide a different application context, obviously that application context will be created as well and put into the cache. So why is this important? It's important because since it's put in static memory, it only works if the tests are executed by the saved JVM. So if you're doing, for example, the Maven Purifier plugin and use the fork count or the fork mode setting, that will cause a second JVM to spin up. And of course, it has not access to the same static context, so that will cause a second application context to be created. And you can see, well, the application context itself, it's rather cheap to create. It's a bean, really. But all the dependencies that you declare, all the beans that you declare, they need to be created, instantiated, dependencies need to be resolved. And especially if you have an ORM mapper like Hibernate, that will also take some time to be inflated. And for that to occur, it's important to know that that will actually occur twice if you create 2 JVMs. And similarly, if you have more JVMs, you will create the same application all over and over again for the different JVMs. So although today it's very natural for us to parallelize things, doing this without thinking, when you do Spring-based testing, you may be surprised that you will not get the performance improvement that you hoped for. So my advice here, if you choose to use this setting, that you really measure to get the performance that you like. If you have lots of tests and you may only have one application context, it still can be beneficial to use this parallelization. However, if you have lots of complex application context and a few tests, then it actually will increase the turnaround time of your tests. In addition to that, if any one of you uses mocked beans, for example, use a mock frameworks like EasyMock or Mockito, if you put one of these mocked beans inside your application context, since the bean is being cached for subsequent tests, that means that any state that you expect from this mock object, it will actually be preserved for the next test. Because normally when you're doing tests with Mockito EasyMock, what you do is you create a new instance of the mock object before each test. And then after each test, it's just dropped and it's garbage collected, and the subsequent test will just recreate the instance. But now it's actually preserved within the cached context. So what do you do to solve this problem? Both Mockito and EasyMock provide reset methods. So what you typically would like to do is, in a before method or in an after method, you make sure to reset the state. So that means that any subsequent test, you will not get a false positive because of the residual test that may or may not be around. Yes?
You're saying with regard to that, if you're just creating a mock object in a setup, that's not unique for each time you run the test?
It depends. I mean, if you create a mock object just in a setup, that will be recreated for each test. However, if you create a Spring bean, that is created from a mock object, so you actually create the mock object that puts it in the application context, that particular bean will be reused for the next tests. And there's also sort of a last thing to know here, that if you create one application context and you deliberately change it somehow, for example, you have the reflection test utils within Spring that uses reflection, can replace private fields inside a bean. Then you can use the dirtiest context annotation. That means that after this particular test has been executed, the cached application context will be marked as dirty, and if a subsequent test uses the same key, it will actually recreate the application context for you. And this annotation can be placed on both the class level and as well as on the method level. So continuing with our project, remember the DevOps and the database guys, they are on the outsourcing partner side and doing firefighting. But somehow they managed to send us a schema, found the time enough to create a schema that we will use throughout the project. And they was although we don't have the complete environment, we don't have any database, it turns out that it's still very useful for us. Because as of Spring 3.0, Spring has very good support for embedding databases. And by using an embedded database, it enables that first a turnaround time for a test suite. It allows us to validate that our ORM mapping works as expected. It also allows us to put the schema into version control, so we can, whenever the schema is updated later on, we can see that it still works. One disadvantage with using the embedded database is that since it's SQL-based, there's many different dialects of SQL out there. So if you're writing an application that is heavily based on application logic within the database, chances are that it will not work that well for you. So if you're using XML-based configuration, this is what the embedded database support looks like. You include the JDBC namespace, and then you just add an embedded database tag. It gives you, in this particular case, an embedded database of HSQL, which is the default one. And if you don't add, you can also use H2 or Derby. Apart from doing this, all you need to do is add the appropriate jar files to your class path. You can also see that I use the script location tag, and that enables the scripts associated with this tag to be executed during startup of this database. So here you can see I have added the DB schema, that is the database schema that the DBA sent us, and then I can also initialize the database with some test data. If you're more into Java configuration, this is how the corresponding Java class would look like. You add that configuration, of course, then you create a bean, and you use the embedded database builder to which you provide a type. And then you can also add the scripts here in the same way. So let's see how that looks in practice. So here you can see I have an application context, and I included an embedded database. And the schema that we received looks like this. So this is basically your normal SQL. The example we look at, we create a table called account. Each account has an account number. Each account has a balance. And the account number is used as the primary key. And since we had this severe server crash, the bank is really careful now. So for now, we only allow a savings account. So we have put a strict constraint validation of balance to be greater than or equal to 0. And this constraint validation will be important later on, so keep that in mind for now. We also have some test data that we play around with. So basically, SQL set is that we create one account with account number 1, which has a balance of 100, and we also create a second account with an account number of 2, which has a balance of 200. And this is what we'll use to verify against when we do database state verifications against the database later on. And you can see here that I choose H2 as my database, and H2 actually has some compatibility mode that we can set. So it's basically this is specific to H2. It's, since we're using MySQL later on in production, that we switch this compatibility mode to MySQL. As I said, we're using JPA for ORM mapping, and so this is where you basically have create your JPA. I won't go into too much details to identify which table is used, the associated columns. And what is interesting for our project is we can get the account number, can get the balance, we can deposit money, we can also withdraw money. And with that, it's time to look into our first test. What we have now is a test database, and we'll base the entire application on top of this. So first of all, we would like to make sure that this test database that we have is up and running and working as expected. So what I will do is I will auto-wire data source and use JDBC template. It's a technology that has been around for ages in Spring, but for this purpose I find it really useful. I do create a small helper method which allows us to query the database. So providing an account number, I get a balance. And if my embedded database is up and running, I can verify that I get the balance from the first account should be equal to 100, and the balance from the second account should be equal to 200. And we execute the tests, and as expected, it passed. So that means that the embedded database that we have configured, not only has it been created, it also has the correct state. Next, I would like to do some validation of our ORM mapper. I'm not too worried about misspelling the names of the table or the columns, but if you have a big table with multiple columns, I do this because I would like to make sure that the correct method is correct. It's mapped to the correct columns. So this is why I did this. And if I execute both tests, in this, since we're using the, obviously it was working because I used the Spring Unit 4 class runner and I have the application context that I mentioned before. But if I look on what's printed here, you can see in the first test, I'm creating some beans of type, that is those beans that are associated with my application context. But looking at the second test, that's actually an output. So that means that the beans were only created in the first test, so that is our caching of the application context kicking in, because if they were created during the second test as well, we would see the same output. Now that we have a database up and running, we can look into transactions. So what is it we're trying to achieve? You have your Spring tests, but if you do database verifications, if you do a write operation to your database, and then the next test comes around and verify against the same entity, if you have done a write operation, that means that you changed the state and your test will fail. Or, if depending on your point of view, it may actually pass. But then when you deploy a test to the integration server, they may execute it in a different order, and then it will fail on the integration test server instead. So prerequisites, of course, is that you have an application that supports transactions, either by using that enabled transaction management or the TX if you're doing Java-based configuration, or you use the TX annotation driven. Given that, you can add transactional annotation to your test. And this will cause that each test in this class will be actually executed within a transaction. So the transaction will start before the test starts, and then you will do your database calls. And after the test has finished, the transaction will roll back. So that means there's actually no state being written to the database or persisted to the database, because each individual test will do their own rollback afterwards. And thus, after the test has completed, the database state of the database is as it was before the test started. We can configure this in some ways by providing a transaction configuration annotation. It allows you to specify exactly which transaction manager to use if you have several of them. It also allows you to specify default rollback policy. So defaults are that if you don't provide this, you will get the transaction manager called transaction manager, and you will always roll back. If you're dealing with JUnit, you used to have the before and at after methods, and they will actually be executed as part of this transaction. If you would like to add stuff before, some setup stuff before the transaction begins, you can use the before transaction, and that will execute before the usual at before annotation. And likewise, if you need to do some cleanup after the transaction has rolled back, you can use the at after transaction. And on a method level that is on an explicit test, you can explicitly configure the rollback policy for that individual test. Next thing to consider when we're dealing with database state verification, that you should make sure to always flush your validation if you're dealing with ORM mappers. Why? Remember the constraint violation that we have in our code? That will not kick in until the objects are serialized. That is, they are written to the database itself. If you're using JPA or Hibernate, you have the entity manager and you have the Hibernate session, and it's likely that they will actually cache your entities. So if you don't flush those, it means that will never be serialized to the database. That means if you have a constraint violation, that may pass unnoticed without you knowing it. So you just execute the test in the background to make sure that everything works. Since we're using JPA here, you can see that I auto-wire an entity manager, and I also auto-wire the account repository that I need. And luckily all tests pass, which means that I can find a repository, I can find my first account, I can make sure the balance works as expected and so on. You can see that I can deposit money into an account, which will change the state of the entity, right? I can withdraw money from the account, so if this were not rolled back, then the state would change and this verification will fail. So if I just change that, disable the rollbacks, you will see that the test will start failing, because since this particular test deals with this state verification of the database, if I change the state of the database, well, subsequent tests will fail. What I did just then was to remove the entity manager. So in this particular case, the test works without flushing to the entity manager, because I deposit money into an account, and since the account is positive, the test passes, although I have not actually flushed the entity to the database. But if I do another test down here, you can see that I expect a constraint validation, because remember that with account number 1, I had a balance of 100, and if I would draw 200 and execute the test, this method here, the flushing, will cause the constraint validation exception to be thrown, and actually the last 2 lines will not be executed. However, by removing the entity.manager.flush in this case, and execute the same test once again, you will notice that this test will actually pass, despite I have a negative balance and despite I have the constraint violation. So that's why you should take care to always flush your entity manager and your Hibernate session when verifying against database states. So we live in a modern world, right? So not everything is SQL anymore. So what? Yeah, sorry. If I should call it the flush on? No, inside actual implementation, you don't need to call the flush method, because the flush will automatically, since we have a transaction boundary, so you do a call into the to the service, which is based on a transaction. That will change somehow the state of the database, and when you escape the transaction boundary on the return path, that will actually trigger the flushing. So that's why the transaction, will take care of that for you. Yes?
Do you have any solution for running those tests in a multi-threaded way?
Yeah, that's a very interesting question. What happens, since we're dealing with transactions here, that will work. But as I show you now, if you don't have any transactions, what will happen then? If you have a NoSQL store, for example, it's not uncommon that we don't have support transactions.
Won't you block it depending on your test?
Yes. Because the transaction will block. So you can only have one write operation, and that will block it. So, but then again, if you have a big test suite and just not doing database verifications, if you do other threads, they can execute other tests at the same time. But what I will show you next is, if you don't have any transactions, you have to deal with this manually. So one way of doing this is that you auto-wire a repository, and before the test, deletes everything that is in there, and then you just save the entities specific to what you like to validate against. And a colleague of mine, he was not too happy about it. It seems a bit harsh to drop the entire state of the entire repository. Can't you just delete the entities you're trying to verify against? But that really doesn't help, because if we're using the same database and two tests write to the same entity, sooner or later there will be a collision, and one will do a write operation and the next will do the read operation, and then we have changed the state. So doing this in parallel, no, I don't think that will work. Not in this setup anyway, unless you can make sure that this particular class is only executed in one thread, because the subsequent test will depend on that the state of the database is as expected. And we'll come back to this later on at the end of and talk a bit more later. Those of you that attended Josh Long's and Kevin Nilsson's presentation yesterday, this is a bit of a repetition on there. So as of Spring 3.1, we have support for Spring Profiles. And in our bank project, it means that since we are using the embedded database in test environment, we're using MySQL in production to get our beans. Those are totally different implementations of a data source. And we would like to support both in a nice way. So the problem we have is that we have two different data sources and declared within our application context. Obviously, we could swap the IDs to have one test data source and we have one production data source. But if you declare two data sources and you do some auto-writing, you only require one, that will cause a collision because Spring does not know which one to use. And the way to solve this is that by adding the nested beans tag, we can put them in different profiles. And by enabling only one profile at a time, that means that we will only get one of the bean implementations. So the profile has the beans tag has a profile attribute, and you just specify the name of the profile. If you use Java configuration, then on your configuration class, you can use that profile annotation, which you give the name of the profile. You can also, for individual components, just add a profile annotation with the name of the profile. And this also obviously applies to whatever service or controller or repository annotation that you have out there. So that is how you specify which bean to belong to a certain profile. And from a testing point of view, now we're interested in actually associating a test with a specific profiles. And for this reason, we have the @active profiles annotation. And it allows you not only to name one profile, but it may be that you depend on several profiles. So you just put them all together there as an array. So in the next application context I would like to show you, I have 3 different profiles. I have the H2 profile, which basically copy-paste of the profile or the bean configuration of the H2 embedded database I showed you before, as you can see here. I also explicitly added the entity managed factory bean because it has some settings. You can see here that I provided H2 setting for it. And I've also created a MySQL profile, which uses the driver manager data source for creating the data source. And it also has some different properties that you can use, because URL, username, passwords, those kind of stuff. And if you could also use things like JNDI in production, and then you just import the JEE namespace and use the JND lookup. And looking at the test, it's pretty similar to, we now test the service layer instead. And if I execute the test, you can see they have enabled the H2 profile here. And if you look on the beans, you will see that they create Hibernate using the H2 dialect. And you can see also that I use the active profiles that's named H2. If I change the profiles to use the MySQL profile instead, as expected, you can see here that we use the JDBC driver. So we look up, and so we actually use the MySQL implementation instead. Oh yeah. So that's how we, sorry.
So one thing that we do is a little bit different. We separate out the data source into a different context file, and then we'll load that context file. You know, we select which sets of context files we load in. We load in one set for the unit tests, and the other ones, for production. Is there any advantages of using the profiles over
So the question is, when should I put the test application context in a separate file and load that during test, whereas in a production environment in another file, whereas you stack them all together in the same file? So, well, personally, I don't have a really good recommendation. What you also can do is you can do both, right? So you separate it out in a separate file, and you import that, and you based on the profile. But it depends. If you have a huge application context, I also used to separate them into separate files just to make sure that, less to read basically. And you just keep scrolling and scrolling, and after a while you get confused which profile is which. So good point. So that is how you configure profiles with regards to tests. And you put into production, you also need to specify a profile, but because if you don't specify the profile, you don't, the beans that are associated with it will not be created, right? And you do that if you're a web application, you provide a context parameter called Spring Profiles.active. If you create your application context yourself, for example, by using an indentation config application context, then you on the environment set active profiles, and please make sure to refresh your application context afterwards. Profiles can also be enabled as an environmental variable. So you add that on the machine you're using. It can also be passed as a VM option to, for example, Maven using the -d flag. So what I just said is that you don't always need to specify your profiles, because Spring also has the notion of default profiles. And default profiles is what you provide if you don't want to add arguments explicitly. But what you need to know about default profiles is that if you apply any other active profile, the default one will be disabled. So typically I use the default profile for my production environment to make sure that it works as expected in production. And when I do the test, I set up my Jenkins environment or my local machine to use the active profiles to override the default ones. Of course, you could switch around as well, but then you have to make sure that your production environment does not use your test database. It works pretty much in the same way. Environmental properties use the Spring Profiles.default instead. Use the set default method on the get environment. Web application use the Spring Profiles default context parameter. And there's also a shortcut, because Spring has under the hood a default profile named default. So this you can use. It will be there unless you specify an active profile. And you can use that by using that profile annotation or the XML configuration. But I tend not to use this kind of setup because I would like to be specific about making sure that if I use a default profile, I'd explicitly tell which is the default, because this is somewhat hidden in my opinion. Also important when you're using profile is consider when not to use them. Sometimes all you need is a basic properties file. For example, if you have a SQL environment like this, if you don't use the embedded database and all that is different between your development, staging, and production environment, are the URL, the username and password for each environment respectively, then there's really no need to create a separate profile for that, right? Because the implementation, we use the same class when we instantiate the access to the database, whereas in the previous example, when I had an embedded database, it's completely different from the MySQL database. But if you only have used MySQL database, well, properties, that's really all you need. And then you let the property source placeholder configure do the work for you. Sometimes if you're a Maven user, you just add a Maven profile instead. The major difference between between using a Maven profile and a Spring profile is that the Maven profile will actually create your artifacts during build time. So that will resolve the dependencies, which allows you to have a smaller footprint of your application. And you can create different binaries based on that. Whereas the Spring profile is decided until deploy time, which the beans that will actually be used. So testing the controller layer of the application. Maybe some of you may have been watched this already. We use the Spring MVC Test Framework, which is a really great addition to testing the controllers. It's possible to do it before that, but it was really awkward. So the Spring MVC Test Framework was added as part of Spring 3.2. And those of you that works on Spring 3.1, you can use the Spring Test MVC project instead. It's compatible with Spring 3.1. It works in a slightly different way, but there's some differences, but the concept is pretty much the same. So the way it works is it calls your controller through the dispatcher servlet. Yes?
Do you know if there's going to be any changes in Spring 4.0?
With regards to the
With regards to the testing that you're showing here, I mean, you just said that the Spring MVC became available in Spring 3.2.
yes.
What changes, if any, are in Spring 4.0?
As far as I know, the Spring MVC Test Framework, there will be no changes to the existing functionality. I did not attend the session, so I do not know if there will be any addition to that, but I don't expect the existing things to change. The reason why it was not migrated into Spring 3.1 is that, as I mentioned, there was the Spring Test MVC framework that you can use with Spring 3.1, but there was some trouble reaching a web application context from that, so they had to do some internal changes to enable the web application context inside your tests, and we get to that in a second. So, yeah, you call your controller through the dispatcher servlet, and that enables all your annotations like the request mapping, exception handler, response body, all the things that you're used to with Spring MVC, they will actually be evaluated. And behind the scenes, the Spring MVC Test Framework will create a mock HTTP servlet request for you. And it will add the bodies, it will add headers and all that kind of stuff. And it pass that to your controller. And when the method returns behind the scenes, there will be a mock HTTP servlet response. And that is what you validate and verify against. But you have a nice Fluent API that will show you in just a second. Important to know here that we're not using a serverless container application server. So that will significantly decrease the turnaround time for this kind of test, because otherwise you have to start Tomcat or Jetty or whatever, and yeah, that takes some time, and now you just can basically create a unit test for your controller. The fundamental class of the mock MVC or mock Spring MVC Test Framework is the mock MVC object. In its simplest form, all you need to do is to create a builder method called the mock MVC builders. You call the standalone setup, to which you pass an instance of your controller, and you build it. There's all different kinds of configuration that you can add to this. For example, you can set message converters, validators, interceptors, view resolvers, all different kinds of stuff. So if you need to configure more, this is what you do. That said, this is actually not what you do, because you ask Spring to create an application context for you in which you have all this stuff is already provided, and we see that also. When you verify the way you do assertions is that, first of all, you use this mock MVC instance, and you call the perform method, and then you pass in the HTTP verb that you would like to do. Here's a get operation. You have the put, post, and the rest of the verbs. You specify the URI of your controller. You can add accept headers for content types, and then you do expectations. For example, if you're interested in the response code, you may be interested if the content type is correct that is in the response body. You can do XPath validations. There's also JSON validation if you have a JSON response body. If it's a redirect URL, you can validate that. Model attributes if your controller returns a model and view object. And as I said, the way you normally do this is if you create an application context that reflects your environment. So rather than performing a unit test on a specific controller, we'd like to create the application context not only with your controller, but with all the message converters and potential also the embedded database that we showed before. So we can do a full integration test on this level as well. So having an ordinary Spring test by just adding the @webapp configuration, it will actually enable this test as a web application context test instead. Not only will it create a web application context for us, the web app configuration annotation will also provide the root of the web application. So that means by convention it defaults to the source main web app, which should not be a surprise to you if you're doing web app development. But it's a file system resource, so you can also specify if you have some other route that you would like to use for your web app. So given this annotation, we now can auto-wire a web application context. And in the setup method, rather than using the mock-MVC builder standalone method, we now use the web application context. And that will inflate the entire web application context for us. So first, take a brief look at our controller. What we have here is the account service in our application. And if you just take a look at this method, there's really no logic in here. If we'd like to get an account, we delegate to the account service. If we deposit, Yeah, so as I said, all that this controller does is that we auto-wire an account service into our controller. And if we would like to get an account, we just simply delegate to the service to get the account for us. If we deposit some money to our account, we just delegate, withdraw. So there's really no logic here. So sometimes you hear the expression too simple to test, and this could be such an example, unless what we're really interested in here is all this kind of logic. And that is what the Spring Test MVC frameworks enable us to test. We can verify the request mapping, the method, response status, response bodies, that kinds of stuff. I have two examples here. The first uses the standalone setup. So this basically creates a unit test of a controller. So I instantiate my controller class. And in this example, you should see that I'm not using this a Spring test. I fall back to use Mockito instead. So rather than having the Spring unit forerunner.class, I use the Mockito unit forerunner.class. And by doing that, it enables me to create an account service mock by just adding a mock annotation. So when this test is executed, Mockito will recognize the mock annotation and create a mock object for us. So that is created behind the scene, and in the setup method I have access to an account service mock, which I then can use to set some expectations on. So for example, in my very first test, I expect the account service mock to return an account which I have created here if I just call the get method of 1. And in this test, I did not put any verifications at all. And why? Well, it's because I would like to show you a really good feature of this framework. And that is, rather than doing any expectations, I call the and do, and then I use the mock-mvc result analyst.print method. And that will cause this test to print everything that is associated with this method call. So you can see here the mock HTTP servlet request that I was talking about before. It is being created for us, and not only that, we can see the internal state of it when it's passed to our controller or to our dispatcher servlet. So you can see we're issuing a GET request. You see the request URI, any headers. We can see which handler that was used, and we can even see exactly which method that was called. If exception occurs, you will see them here, and you will also see this mock HTTP servlet response. So whenever you find yourself in trouble knowing what is actually going on when you're writing this kind of test, put in a print method there, and you will see the internal state, and then you quickly realize, oh, I should have called that URI instead, or I should pass in another accept header or whatever. Doing verifications on this stage, then you use the at and expect, as I said, and here we verify the state. And we can also use something called JSON path. And it's similar to XPath, which enables you in a very simple way to use dot annotation to traverse the response body of the actual response. So making things a little bit more complex now, the last example was not a Spring test. So now we do that instead. And here you can see I have a context configuration. I used the application context that I showed you a while ago. And I also have a servlet application context, which is basically component scanning of the packaging which I have my controller. So given that, I have a more complex, I have an entire application context up and running. I use the Webapp configuration annotation, which allows me to create a web application context. And now I can do the mock MVC builders. I can use the Webapp context setup instead, which creates a mock MVC object for me. And since we now have a Spring test, I can also make this transactional, of course. So any state changes into the database that this test suite will be rolled back. Yeah, I didn't show you that before, but you can actually see, since I have logged here, so you can see that rolled back after test execution for test. So it's very clear that the rollback mechanism takes place. Sure. I don't know really. I have not looked into that. That said, you can test your view objects, and anything that is rendered on the server side, if you render JSON template, velocity time leaf, you can use to verify against that. And you can also use HTML unit if you have HTML coming out. There is one important exception, and that is you cannot validate JSP. And why? Well, remember I said we're using the dispatcher servlet. So we're not using any servlet container, and we're not using any application server. So, and JSP will be rendered by that. So that is the important exception. Yeah.
Is that a Spring MVC test annotation?
No, that was a pure Mockito test. If I had a time, if I had a time, I'd show you that in the end. And I think there is time, so I'll save that for now. So now, it seems like we have tested our entire application, right? We tested the persistence layer, we tested the service layer, we have tested the controller layer, we have done with the mock MVC, we have inflated our entire application context and do full top to bottom verification of our application. So do we really need server integration tests anymore? And by server integration test, I mean that we actually deploy our application to either Tomcat running TC server, embedded Yeti, whatever, but we actually do have an application server. And well, it turns out that every now and then you find yourself into a situation when you can't use what I've just showed you. For example, if you have controllers based on Jersey, you cannot use the Spring MVC Test Framework anymore. It could also be that you have a staging environment that you would make sure that you use the correct profile, so we don't use the embedded database anymore, then this could be useful. It could also be that you're integrating with a third-party server. And of course, you probably cannot access their database, but you can do behavioral verification. So server integration test still has a role. Before looking into that, first a recap of what we just did. So basically, we create a test, and the test then creates an application context, a Spring application context for us. Inside the application context, we created an embedded database, and then we created some beans associated with that. And we have the data source, transaction manager, repositories, and all the other beans in our application context. The important thing to know here is that the test has direct access to any bean within the application context. So we can auto-wire all beans from the application context into our test, and that changes things. Because if we deploy this on a server, the server creates the application context for us. So the application context now is hidden within the app server. So when we create a test, we really cannot access it. Because what we do now is issuing HTTP requests with maybe some messaging or socket communication or whatever. But the important thing to notice here that we don't have access to, in particular, the transaction manager. So we cannot roll back any state changes we do on the server side. And now it depends really on the environment. If it's a third-party application, we can only, as I said, we can only do behavioral tests. If it's our either local environment to our local machines or maybe a development environment, what we can do is that we pull out the state of the database. So rather than having an embedded database, we now have a proper database up and running. And when we create a test, we let the test create a second application context. So the bean definitions can be pretty much copy-paste, or you can use the same bean definitions as we do within the application, but they will be different instances because they reside in a different application context. So given that, and we can use the same kind of data source and we can access the same database. And now, when we're issuing requests to a server, the server does what it's supposed to do. It goes down to the database, changes the state, and now we can use the test to verify against the same database. And returning to your question earlier, what is the drawback of using this kind of setup? Well, we can run into race conditions here. If we're doing multiple requests in different threads, they may change the state of the database concurrently and this test will start to fail. And important to know here is we cannot put a transaction manager within our test application context, because the transaction manager that is used within the application server would actually commit its transactions after it has finished, and that is before the request coming into the server returns a response to the server. So you with me here? So there's a separate transaction manager within the application server. When the request comes in, to write the state to the database, and before the response coming back to our test, the transaction manager in the application server has committed a result. So whatever we're doing over here in the test, even though we had a second transaction manager here, it would not know that there was another transaction going on over here, so we cannot roll back that. So how can a test configuration or a test environment based on this approach look like? Those of you using Maven, there's a Get the Maven plugin that you can use. The way you do it is you hook into the integration test phase of Maven. You know that you have different phases of mailing. First, you will compile phase, then you have the test phase, the package phase. And after the package phase, there's a second test phase called the integration test phase. And this is done because what you usually do is in the normal test phase, you have your quick small test based on unit that have a quick turnaround time. But the integration test phase, by hooking, for example, the Get the Maven plugin, you can, in the pre-integration test phase, you can start Yeti at Yeti server, and which creates application context for you. And then during the test, you have this server up and running. And after, in the post-integration test phase, you tear down Yeti again. Important if you use Get the Maven plugin, you would like to know that you should use the group ID of org eclipse.yeti, because there's an old version of this that is not maintained anymore. Apart from that, since we now have two different kinds of tests, we have the unit tests that execute in the test phase, and we have the integration tests that execute in the integration test phase. We need a way of distinguish between them, because if you're trying to execute the integration test phase in the normal test phase, well, there's no app server for you, so those tests will fail. What you do then is you use the Maven failsafe plugin, which has naming conventions. So you use the IT asterisk or asterisk IT or asterisk IT case. And by using these naming conventions, they will be recognized by the Maven failsafe plugin. So they will actually be executed within the integration test phase instead. If you don't like those naming conventions, you can specify your own. So now we showed you that we have application server that it starts up. We know which test to execute, and then there's the question: how do we validate the REST service? Well, since we're Java developers, as always, there's tons of different frameworks out there that we can use. Spring users like us, we can use the REST template. You can use Selenium for those of you that are more into web development. You could use the Apache HTTP client as well, I guess, but, well, I would not recommend that. Another option is a framework, open source framework developed by a colleague of mine called Rest Assured. And it's similar to what you see in the Spring Test MVC framework. It provides a Fluent API to do both provide the request for you and to validate the response. So rest assured is based on Groovy. So under the hood, it uses the XML slurper and the JSON slurper for XML validation and JSON validation respectively. You don't really need to know that you're using Groovy, because what you will see in a while is that it's a basic text string that you can provide. For those of you that are interested in Groovy, you will be happy to know that you can use methods like the findAll method in Groovy, which provides a closure, Groovy closure, so you can use the bracket syntax for the IT and provide a closure in which you can do all different kinds of things, with kind of maximum value of a collection, minimum value, calculate the sum of a collection, and those kind of stuff. So what I've done now is also I've created a Maven profile, because if I only would like to have a quick turnaround time of executing my unit tests, or if I'm making a build pipeline, I would like to make sure that I run my unit test first, and then in the second stage of build pipeline, I execute my integration test. So that's why I have created a Maven profile. And here you can see that I've been using the Maven failsafe plugin, and I use that and the integration test goal of that, and I also use it to verify goal. And here you can see you have the get the Maven plugin, and there's some properties that you need to configure. Stop key and stop port, so Maven knows how to shut get it down after it's running. And during the pre-integration test phase, you execute the run goal, and during the post-integration test, you execute the stop goal. So that will cause, whenever you execute your Maven build, it will start and stop automatically. And returning to what I said about database state, now I will do some tests, so I will actually change the state of the database, but since I run the database on my machine, it also allows me to explicitly set the state of the database to a known state, so I can do that kind of verification. And here I simply drop or truncate the table that I'm working against. And yet again, this does not parallelize very well, but it allows me to always make sure that I always have the known state, so I always have the same kind of values. You could also, if you don't like the SQL here, you could, from this application context, you can fetch the repository that we use and then just drop everything and insert the test data that we need. So what you see here is rest assured. And similarly, like the Spring Test MVC framework, we also have logging methods, so you can see what's going on. Of course, we cannot see the internals of Spring anymore because we do this test from the outside. So this could be a black box third-party server somewhere. So here you can see we're passing into rest assured. Request method, paths, params, cookies, request body if any. And here you can see the response coming back out. And the way to use rest assured is it's have a more BDD-like syntax. So you have given, then when. So here I have secured my application, so I can provide basic authentication. But if I, for example, could also use some other kind of certificate verification, digest verification, form verification. If I would like to pass in request parameters, I can easily add them here, as you can see. I could also do basically all kind of modern web development nowadays. You can have cookies, you can have multi-part upload if you're dealing with files and uploading. And now I have started an application server in the background, and when I issue the request, you can see that it's coming back, the response, and verify against account number and the balance. It's pretty much the same thing. So this is the JSON slurper taking place. And if I just show you what the response looks like that we're verifying, you can see that it's a nice syntax. And if I had more complex structures here, I could just use dot annotations to go could traverse sort of the response body. I have a more interesting example here. Because here you can see that rather than passing in here I use the Groovy closure, so I use the find all method. And you can see I use the it closure here, but here you can also pass in any Groovy code that you like. You can use filtering and mapping, reducing. This was just a simple array that I passed in, so I can verify for first finding all elements and traversing them, and then I pass in a hamcrest match it to see that I have it has contains both items 1 and 2. So you can see that I also use the MySQL profile. If I change or accidentally change to use the H2 profile instead, and I restart my server, I'm starting the server based on the H2 profile. What would you expect to happen? With MySQL, all the tests pass because we're using a single database. But if I accidentally use the embedded database instead, and I execute the same test suite, you see that I have a couple of tests fail. And that is, again, you have to be very careful that when you're using the embedded database, like when I kick off the application server, that application context associated with that created one embedded database for me. But when we're using this integration test and using the H2 profile, I will actually have a second H2 database instance associated with that. So I'm actually not issuing a request to the application to the database in the application server, which changes its state, but I do verifications against the other one. Yeah, we have a little bit of time left, so I briefly present Mockito. I find Mockito very useful when writing unit tests for Spring beans. Or it could be any beans, it could be enterprise Java beans as well. So imagine you would like to test your account repository, or that is, you would like to test account service impl class here. The account service impl has a dependency on an account repository. But now we would like to mock away that dependency so we can test the application logic within the application service. So the Mockito way of doing this is that you create a mock object of your account repository. And that is simple by just adding a mock. But in order for that Mockito to recognize this annotation, we need to execute it with the Mockito unit runner. So that will go out, fetch any mock objects, and create an instance, instantiate them for you. And next is the really cool annotation. By using the @inject marks, we'll actually instantiate the account service impl for you. But not only that, any dependencies that have been marked will actually be automatically injected into the account service. And Mockito does so by reflection, and it supports 3 different kinds of dependency injection mechanism. First of all, it will try to find a matching constructor. If that fails, it will try to find matching setters. And the last, it will try to use field injections. Yeah, the last, as a last resort, it will do field injection. So any auto-wide, if you just put auto-wide annotation or an inject annotation on your field. And the good news is that since we're using, it's based on reflection, there's no dependency for this test on either Spring or any Java EU components. On the other hand, the bad news is it will only use one of these dependency mechanisms. So if it finds a matching constructor, it will auto-wire, or it will use that and provide your mocked beans into the constructor, but any setter dependency you might have afterwards, they will actually not be used. And likewise, if you have setter injections and there's also a field that you need to set, the field will not be set. So you have to be a bit cautious when you're designing the bean you're trying to create. All that is documented within the Java doc of the inject mocks of the inject mocks class. And when dealing with Mockito, you have a very nice syntax. So basically, you tell when something happened, when is a static import from Mockito. So here, when I call the doIt method of the repository mock, I tell Mockito to then return a specific value. So in this example, I have using the Mockito unit runner, I have the account repository being mocked for me. And yeah, what's lazy here, so this is basically a result value. So here you can, and I should also, guess I should show you the implementation of the account service impl. In this particular example, I'm using auto-wiring on the constructor, so any constructor, any matching mocked beans matching this constructor will cause this one to be used. And the Mockito way of doing things is when I call this repository mock with a specific method, you can also use hamcrest matches here, so you can find any instance of a specific class. Then I expect to return something. And here I can see that it expects the deposit method was just a simple delegation. So calling the account repository save method. And most times I do the verification here, but that is in this test makes sense. But usually, depending on what you're trying to achieve, often you don't need to verify something, because as when you do your mock expectations, just giving the return value here, that means that another method that is using this return value, it means that the mock object was actually called, because otherwise you would not get a return value. Okay, to wrap up, what we've seen here, we discussed the Spring basic testing. We started off very simple with the context configuration annotation and Spring Unit 400 class, but we also went in to discuss more details about the caching mechanism, how that works. We also seen the embedded database, how that works. And well, you can use the embedded database for any project. I mean, it's not just for testing purposes. If your application needs some kind of database and you don't want to have complete database server up and running, you can use the embedded database, of course. We also take a look at how the transactions with rollback, how that can simplify the state verification of database and improve the performance. We looked on profiles, what benefits they gave us, and we also discussed when not to use them. We have seen the Spring Test MVC framework, just a touch of it really, because there's a lot of things to explore. And we also discussed some server integration tests. So with this, I hope that I've shown you some new tools that you can go home and start using on Monday. And there's really a lot of more to learn and to explore about this, but now you have some ideas where to look and what is available there for you. And do we have any more questions?
As far as integration testing goes, what if you have more complex scenarios where web services are invoked by the application you're testing? Can you just deploy those services along with the other Webapp embedded server?
So if I have more complex scenarios, we have a Webapp service that are deployed, and then I would issue tests towards them. Yeah, and then they in turn call a remote web service. What I would try to do is the second call to the remote web service, if I could somehow fake that in a way, perhaps by setting up, either by doing completely remove that somehow, just making stub implementation of it. If it's a remote, do I have control of the remote server as well? Then I could probably perhaps do some state there, but I think that's too complex. So, and I probably just test the integration point with that external third-party server in its own, and just make sure that I have the path going. So I have either my own sort of fake third-party server instead, or just stub it away entirely. So this is where you can reach me, either on Twitter, send me an email. I write occasional blog posts every now and then. And well, realizing that I'm the only thing between you and lunch, I thank you for your attention.